If you wanted to test something that was going on the moon, how would you do it? Well, for sure, you'd have to perfect everything before you get it up there, right?
Yeah, exactly. How do you make sure the things you're testing down here on Earth will work at their best in a much more hostile environment like the Moon or Mars? I guess one way would be through computer modeling, right?
Yeah, that'll definitely help. But you know, when it comes right down to it, you still have to physically build and test real equipment to make sure that it's ready for the big show up there. Hey, I'm Johnny Alonzo.
And I'm Jennifer Pulley, and today on NASA 360, we're going to find out how NASA researchers conduct analog field tests to make sure the equipment we're building for next-generation space missions will work correctly, hundreds of thousands of miles away from the comforts of Earth.
Our world has changed a ton since we first landed on the moon back in 1969. I mean, just think about it. Cell phones, personal computers, digital cameras, and even iPods. The list goes on and on. So, with all the changes since '69, it's pretty obvious we're not going to be using the same old equipment and tools to get us back to the moon. Nah, we got to update them and use the most modern technology available today.
That's right. And think about this. The Apollo lander that carried Neil Armstrong and Buzz Aldrin to the moon had less computing power than a dollar store calculator does today. Well, with that as an example, we know that everything else we took to the moon in the 1960s has to be completely updated. Today, NASA is in the process of testing new designs that will get us back to the moon and onto Mars. And of course, lots of testing can be done in labs. But eventually, you have to test equipment in real-world environments and situations. This type of testing is called analog testing, and it can be done almost anywhere. Underwater, in volcanic environments.
To very remote desert environments like here. Today, I'm just outside Flagstaff, Arizona, the Black Point lava flow. Now this is where NASA researchers are testing equipment that one day may make it to the moon. Now this testing is called Desert Research and Technology Studies. But most of us, well, we just call it desert rats, or DRATs for short. Now, as we said before, when you're doing analog testing, you have to mimic the extraplanetary environment as best as you can. Turns out, here in Arizona, some of the terrain is really a close match with the moon. So NASA boxed up lots of equipment and shipped it out here to the desert to see how it all works. I spoke with a few of my buddies to find out a little more about what's being tested out here. All right, follow me. Let's talk to somebody that knows something about analog testing. It's my buddy Zane Nye. Yo, what's up, man?
Hey, how's it going?
Good to see you, man.
Good to see you.
Tell me a little bit about analog testing. DRATs.
Well, we're out here in the desert because this kind of gives us a feel a little bit like what a lunar surface is like.
Okay.
And so what NASA's trying to do is to determine what is the efficiencies we need within our systems to operate appropriately on the moon. And so what happens is when you start building hardware, it gets a little bit complex.
Sure.
And so we can't really take those and put those in a lab and test them because labs just aren't big enough for some of the things we're doing. Like for instance, we just did about a 100-kilometer test where we ran the rover, the LER, which you may have seen earlier, around this whole site. And we went and found geological sites where we actually tested the geology. We had evaluations of the crew on board. We had evaluations of the vehicle and its systems and how it's operating. And so this is kind of like a really large laboratory. And so the analogs, what they allow us to do is to basically try to bring some of the things that are really hard to evaluate down into a more of a scientific evaluation to determine if the end result that we really want is efficient. So some of the things that we're doing, for instance, is we're running the LER for a long distance over rough territory to see how it holds up, to beat it up a little bit, to determine what type of hardware we need to build for the lunar surface. Some of the other things which you might be seeing behind us right now is the Lance blade. And this is another objective of, okay, when we go to the lunar surface, we're going to build berms and we have to build landing sites because the surface is not really hospitable for really landing or operating on. So basically what we're doing is we're combining all these other groups' objectives into one so that we can run a real mission and let the hardware tell us if the ops concept is right, and in reciprocal, tell us if the ops concept meets the hardware.
All right, so Zane, is this like the only place in the world, to do like lunar surface testing, similar to the lunar surface testing?
Well, actually no. What this provides is a geology-rich environment that we actually know. This place has been discovered. What it allows us to do is have a controlled environment. Okay. So we could go explore someplace we've never explored before, but now we're exploring, so it's hard to gauge. Are we really exploring it right? What is the efficiency of the exploration from a geology standpoint? Right. So what we have here on this ground is the ability of the geologist to know what they're really looking at and determine what is the crew looking at, and did they really see at each individual site what they expected to see. And so from that standpoint, this is a really good ground. Now, if you take a pan around, you can see there's a lot of grass, there's a lot of trees, and there's a lot of wildlife. So obviously on the lunar surface, we don't have any of that. But what we do have is a large lava flow. What it allows them to do is explore in the operational content the way we would be exploring the lunar surface. So it's very good. But there are other places that we're looking at, and there are other places we may use, but right now this is a very good database for us.
Very cool. Zane, thank you so much, man.
No problem.